Okay, students. So we are going to discuss today practice paper 5 for 2027 A-level batch. So in this paper, we have 10 MCQs to discuss, 8 MCQs from atomic structure, and there are 2 MCQs from chemical calculations. Okay, so this is the paper we are discussing today, right? So we'll start from the first MCQ. It is about successive ionization energy. This is the topic we discussed in our theory class in last week. Okay, so successive ionization energy is an evidence for existence of energy levels. Okay, so in Bohr model, it is explained first the existence of energy levels, and there are two evidences for Bohr model. One is the successive ionization energy. Okay, and the other evidence is uh, hydrogen emission spectrum, which we are going to start studying this week. Right, so let's start from the first one. The first 7 successive ionization energies of an element that located between lithium and neon in the periodic table are as follows, right? So there are 7 ionization energy values are given. So if I briefly tell you what is this successive ionization energy, so we are removing electrons one by one. Okay, so this 1310 is the energy required to remove the first electron, and then 3390 is the energy required to remove the second electron. Okay, like that. From an element, from an atom of an element, we are removing electrons one by one. That is what we call as successive ionization energy. Okay, and then as we discussed in the theory class, successive ionization energy should be increased. Okay, should be increased because once we remove electrons, the net positive charge in the nucleus is increasing. Okay, that again gives a higher nuclear attraction on the remaining electron. So removal of electrons should be difficult gradually according to that theory. But you can see here, Lamai, if you carefully go through the values, you will see between this 13,300 value, and you can see the next value is 71,000 something. 71,000 actually, that's the value. So you can see it's a very sharp increment. Okay, so rapid increment, you can give many names for that one, but the idea is you will see a sharp, remarkable increase of ionization energy during some successive ionization energies. Okay, that is an evidence for the existence of energy levels. Okay, you can understand the electrons that were removed easily, kind of, you can see it's gradually increased now from 1300 to 13,000, it gradually increased. So those how many electrons are there? 6 electrons, no? Those 6 electrons can be removed easily. When you are removing the 7th electron, now it has become very difficult. Okay, so that means Lamai, 6 electrons are there in the outer energy level, and the 71,000 energy electron is there in the inner energy level. Okay, so you can draw it in this way. Right, let's say this is the nucleus. Okay, this is the nucleus, and there are 6 electrons in outer energy level of this element. Okay, so those 6 electrons are removed easily because they are feeling a lesser nuclear attraction because of their high distance. Okay, but this inner electron, okay, there may be many electrons, we don't know that yet, but that inner electron removal has become difficult. Okay, so this is what the summary for the first MCQ. Okay, so these 6 electrons are removed easily. You can write 6 electrons are removed easily. Okay, removed easily. Therefore, those electrons are in the outer energy level. So you have outer energy level, you have 6 electrons. But that removal of this electron has become now very difficult. Okay, so difficult to remove. Okay, that doesn't mean in the inner energy level you have only 1 electron. Okay, you may have several other electrons, but they have given only for 1 electron. Okay, so difficult to remove. Difficult to remove. So that must be in inner energy level. Okay, inner energy level. Is that clear to you all, Lama? Is there any doubt you have here? Okay, so this question is asking what is that element? Okay, what is that element? So basically, if you get the elements from lithium to neon, that is actually Puta, our second period elements: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. You will be given a periodic table also. Okay, so there's no problem. So if you take lithium, lithium has only one electron in the outer shell, two electrons, three, four, five, six, seven, eight. These are the outer electron, number of outer electrons, number of outer electrons. So you have six outer electrons in element oxygen. Understood? So that is our answer. That is our answer. So answer should be oxygen. So this is the same question you did in the theory class. But in the theory class, it asks about how many electrons are there. So now this question is improved, asking what is the element. Yeah, look at your answers. I have 24 answers with me now. So for the first MCQ, 20 of you have selected the correct answer. That's very good. Okay, that's very good. Right, so some of you have been confused regarding the nitrogen also, only two of you. So carefully see, Lamai, carefully see. The largest difference is there between the sixth and the seventh ionization energies. Understood? So this is how we actually see it. Okay. So now see, if you are having a value greater than the twice of the earlier value, then it must be removed from a energy, inner energy level. Okay, you can see 13,000 twice is 26,000, but our 71,000 is far more greater than that value. Okay, so I hope you understand that simple logic. Okay, right. Yeah, we can check this one once again. There is another question. So I hope that is clear. Shall we go to the next MCQ? Question number 2. And that one is also a very good MCQ. This is actually I obtained from a term test paper of a Colombo school. And this is a really good MCQ. Okay, this is actually the best MCQ I have seen from this topic. Okay, so I'm curious to see how many of you got the proper answer. For the second MCQ, yeah, it's very good, right? So out of the 24 students are answered, yeah, 23 of you got the correct answer. That's very good. That's very good. Right. So I couldn't appreciate last week. Some of you were able to got, there were like 10 MCQs no earlier also. So 10 out of 10. This today also we have several students who got all the questions correct. Okay. So because nobody can say these questions are that much easy, right? These are kind of good questions are also there, right? You have chemical calculations also, no? Right? There is a chance of getting that wrong, but still there are good marks I can see from you. That is a very good thing. So let's keep that one. Let's continue that one. That is what important one. Eh? Okay, you can't write A levels with two lessons, right? There are like 14 lessons in our syllabus. So you have to keep this energy, keep this momentum, keep this consistency for the rest of the whole 2 years. Okay, you can do that one, right? You can do that one. Just do the work that you have to do weekly. That is enough, right? Don't think about the bigger challenge you have ahead. Just think about this week. Okay, then you can think about the next week. Like that, you can go. Right. So I'm going to put this reaction in the board. Then I'll balance this one with you. Okay, just to explain the method. Right. So there are like 4 nuclear reactions: X, A, B, and alpha. They have just given you alpha, right? Alpha. So when I'm writing this one in the board, I'm going to put what is alpha also. So alpha is helium nuclei. Okay, so it's having a proton number 2 and neutron nucleon number 4. Okay, so if you are not familiar with the proton number and nucleon number, if you have forgotten that theory, you can go and refer our last week recordings also. There you have nicely explained everything. Okay, right. So it's going to give you mgh particle and ydf. Okay, right. Then you have this ydf, that particle is giving you h11 and a beta particle So beta is -1, 0. Beta are equivalent to electron. Understood? So this reaction is somewhat important. Okay. So what is this particle? H11. Somebody can say this is hydrogen atom, but that is hydrogen atom. I'm not telling it is false, but you can tell this as proton also. This is how you represent proton, isn't it? Right? Proton. And this is what? You can say this is an electron or beta particle. So proton and electron are given by whom? If you balance this side, you will see +1 -1 cancels to give you 0. That is the proton number, which represents the charge. Okay, 0 charge. Then if you check the masses, here the neutron number, it is equal to 1. So what is this particle? Which is having a 0 proton number and 1 mass number. What is this particle? Can you put it in the chat? What is this Y? What is this Y? Huh? Right, so I'm going to write the rest until you put the answer. MgH is again reacting with beta -1, 0 is giving you gamma, no charge, no mass, and again that mysterious particle YDF. So YDF is very common, must be some particle Kn. Yeah, so what is that? Okay, very good. I have some answers. That is neutron. This one is my neutron. Okay, so this is neutron. Okay, so you can see now a neutron in nuclear reactions. This can happen. Okay, neutron will be broken into a proton and electron. Okay, it is not just happening in nature. It is happening in only in radioactivity. Okay, so this is some process that involves a huge energy. Normally this won't happen, right? But in unstable nuclei, within unstable nuclei, this can happen. Okay, right. Now we can start balancing. So since we know this is neutron, let's see where else we have this particle. You can go to the last reaction, then you can balance the last one. So Q, Kn with alpha 24, helium nucleus, and carbon 612, and then you have again our YDF. So you can say YDF means what now? So I'm going to replace them later. So first of all, you can start balancing from this reaction. Secondly, you can go to this. Okay. So now we can say this YDF. This is actually 0. This is equal to 0 and this is equal to 1. Okay. So then this side you can balance. Here 13, here 4, and this should be 9. And here 6, 0, 6. And here 2 is there. Then it should be 4. Like that you can start balancing. Now you can put this. Now you can go to third one, this one. Okay, so here now you know Q, it is 4 and 9, and this one you know 0 and 1, right? In this side, so you have 10, it should be like equal to 10. It's very simple now, right? 4 and it should be 5. Okay, so MgH, it is 5 and 10, and this is 0 and 1. You can see why I like this question so much, right? It's going through several steps, so student can get wrong in any place, right? Any simplification error will give a different answer, right? So anyway, here it is 5, so 2, it must be 3, and there is only one answer, I believe, that having a proton number 3. So then you have your answer, but still let's finish the question. Here it is 11 and 4, it must be 7. So here you have your answer. So the element that is having proton number or mass atomic number 3 is lithium. So your answer is going to be lithium 37. Okay. So like I showed you earlier, those who answered majority, right? Vast majority got the correct answer. That's very good. Yeah, that's very good. So again, I'm going to remind that advice. So you have to keep this energy continuously. Okay. So I'm there to remind you whenever you, deviate from your path, right? I'm there to guide you. Okay. So no problem. There are papers, enough papers to do. So that will sharp you, that will get you ready for that big challenge you have within after 2 years. Okay, right. So very good. You have to start from the middle equation, and then you have to go to the last one, then balance third one, then finally you can go to the final, the where the x is actually there. Okay, so it's a good question. Right. So any doubts on this question, Raman? Anything to ask? Shall you go to there are two chemical calculations actually. Both the questions are very nice, very good questions. So let's focus on those. Okay. So this is our chemical calculation MCQ. I want to see again how many of you got the correct answer. That one. Now we can see some clear division of the answers, right? So majority got the correct answer still. That's very good. Out of the 25 answers I'm having, 14 of you got the second answer. That's very good. That means 66.66 is the correct answer. And 6 of you have taken the third answer as well, that which is 50%. Okay, so those who got, here's what we are going to do, right? So I'm going to explain the question how the second answer is coming. Okay, so once you now through the student who got the answer as the third one, okay, have to focus more on the method how we are going to get the answer. So if you are having still a doubt, please tell me. Okay, you have to discuss it with me. At least you can send a message, you can send a voice note, or you can personally ask that question to explain more during the theory class. Even after the theory class, I can save some time for you and I can discuss that question with you, right? So take every benefit you are having, okay? Right, so I've been doing this one for like 9 years. This is my 10th year, so I have kind of experience, right? So that one is a very good resource for you. Okay, so try to take that benefit. You can always ask Raman. Okay, so I'm going to explain commonly. So if you are still having a doubt, that's what I'm telling. Okay, that means this question is a good one. So if you are still having a doubt, please ask. Right, so let's go to the question and see. So I'm going to show you one more time the question. So under standard conditions, ethanol reacts with O2 to give carbon dioxide and water as the only products. Okay, and they have given you some data regarding the two reactants about ethanol and oxygen. And it is asking what is the percentage of ethanol remaining after the reaction. Okay, so let's see how to do that question. So first of all, we are having a chemical reaction which we need to balance. So ethanol C2H5OH. Okay, so the formula is given. So it is going to react with oxygen to give you carbon dioxide and water. Carbon dioxide and water. So there are two carbon atoms. So 2 carbon dioxide is going to give you. Okay, and then you have 6 hydrogen atoms. You have 5 here and 1 here. So which is going to give you 3 oxygen, sorry, 3 water molecules. Okay, so altogether you are having here 3 oxygen and here you have 4 oxygen, altogether 7 oxygen. Out of that, 1 is already there. So you need 6 more oxygen atoms, that means 3 O2. Okay, so however, if you put inspection method also, still you can balance. And the one I did here, I'm going to teach you once again in few weeks, right? So the how did I balance it? Okay, so you are putting the, I'm going to erase this one, so write it down with me. You are putting the number of carbon, you are putting to equal carbon dioxide molecules equal to the number of carbon atoms, and you are getting the total hydrogen atoms. You are having 6 hydrogen, and then you divide it by 2 and put number of water, because in water molecule you have 2 hydrogen, and then you find how many oxygen atoms are needed. So altogether you have 7 oxygen atoms. From that 7 oxygen atom, already you have 1 here. So then what you are doing, you are 7 minus 1, and then you are going to divide it by 2 and add to the oxygen. This is how we get the balanced reaction. Okay, so that one is needed for you first of all. Okay, right. And then we need to find some number of moles of ethanol and oxygen. Here, what is important, Lamai, the way they gave data for the ethanol. This one we all have to focus, because this is the first time we are seeing such a method. Okay, so now let's focus on that one. So is there any problem with the balancing or anything before we go to the other part? Now look at the data. 27.6 cubic centimeters of ethanol. So you have the volume of ethanol. Volume of ethanol, C2H5OH. Volume, you have 26, sorry, 27.6. 27.6 cubic centimeters you have from ethanol. Okay, and it is Lamai a solution, no? It's a liquid. It's a liquid ethanol. And then they have given about the density also. So from this we can take the mass of ethanol, C2H5OH mass. So what do? We multiply the density into volume. So what is our density? Density is given like 0.5 grams per cubic centimeter, and then we multiply it by the volume, 27.6 centimeter cube. Okay, 27.6 centimeter cube. From this you will get the grams of ethanol we are having. Okay, grams of ethanol we are having, and then you can then find moles of ethanol. Moles of ethanol, C2H5OH, or you can just put the symbol N here. So what we are going to do, we have this number of grams, and we are going to divide it by ethanol molar mass. Ethanol molar mass, there are 2 carbon atoms, so 12 into 2, and then we have to add 1 into 6 for hydrogen, and then we have to add 16. Okay, so 24 plus 16, 40, 46. So you are having 46 grams per mole. 46 grams more. Okay, so we have to divide this one to get the answer. Okay, so 0.3 moles are added from ethanol. Okay, like that simply. So that is the number of moles of ethanol added. So that's what I want to highlight, Laman. This method we followed here was the first time we are seeing in a question in our class. So then study it. How did I get that answer? So it is given a volume. Okay, volume of a liquid. So you multiply it by the density, you get the mass of ethanol, then you go into the moles of ethanol. It's a very interesting one. Okay, so do we have any doubt here? Yeah, so I'm having a question. Why can't we get the number of moles of ethanol using the formula of molar volume? Yeah, okay, a very good question, right? So why can't we use molar volume? So you can see one word written in the board. Huh? What is that? Ethanol is a liquid. Okay, so that molar volume formula I teach you in the class is applicable only for what? Gases. Understood, Puta? If it is a gas, then you can divide it by the molar volume and get the number of moles. Okay, those who remember will understand what it is. So the next question we have to do with this one. So anyway, you can't use molar volume formula because it is not a gas. Okay, so is that clear? Then there is another problem. To find the mass, we have to multiply density into volume. That is the formula. Okay, so you're asking for the formula here. Here's nothing new, Lamai, actually, right? This formula is kind of a derived one. So the original formula is density equals what? It was there in your earlier grades. Mass over volume. Total mass over total volume. Okay, so that means D equal M over V. So I change the subject of this formula. So if you want to remember something, remember this formula. So when you need something, you can change the subject and get it. Okay, so are there any more problems? Okay, good. Ask like that. Right, so now we found number of moles of ethanol. So then there is another data given about the volume of oxygen gas. Now it is a gas. Now it is a gas. Okay, so if you consider is the ethanol, if you consider oxygen, it has given the volume of oxygen. It is a gas now. The volume is 6.72 decimeter cube. Now we can use that molar volume formula. So you can find number of moles of gases by dividing the volume from its molar volume. Okay, so that means 6.72 decimeter cube. You are going to divide by the molar volume at standard temperature pressure, which is 22.4 decimeter cube per mole. Okay, 22.4 decimeter cube per mole. Is that clear, Lamai? So now we are applying this formula because it is a gas. Here we can't apply that. Okay, that confusion might be there with many of you. That's why I especially put a star here also. Is that clear, Lamai? So it's here again divisible. Again you will be getting 0.3 moles as the number of moles. Okay, 0.3. Now we know number of moles of each reactant. Now we can peacefully apply what? When you know data regarding more than one reactant, they have given data regarding more than one reactant, we have to apply ARR method. Added, reacted, and remaining. Okay, so good, very good question, huh? So we're going to apply that one. ARR, added, reacted, remaining. So from ethanol, we know there are 0.3 number of moles, and from this also we know 0.3 moles are there, right? And then what shall we do? Okay, so now they are going to react, and they react in 1:3 ratio. 1:3 ratio, which means with 3 moles of oxygen, you need 1 mole of ethanol. Okay, now look at the numbers. You have 0.3 moles of oxygen. Okay, so you will be needing 0.1 mole of ethanol. Understood? To react with 0.3 moles of ethanol, you will be needing 0.9 moles of oxygen. We don't have that much. Understood? Do you remember the two sentences we are writing? So I'm going to write it here as well, but I'm going to later erase that one, so you can write it with me. Okay, the two sentences, it is really important. You can say like this: 0.3 moles of ethanol, we need 0.3 into 3, which is 0.9 mole of oxygen. But we don't have that much. But we do not have that much. Therefore, what? Therefore, oxygen is limiting, ethanol is excess. ethanol is excess. Okay, so now we understand that whole ethanol is not going to react, some amount is going to remain. Understood? Then we can write about in the perspective of oxygen. Let's say when you want to react this oxygen. Okay, so let's write to react with 0.3 moles of oxygen. Okay, so write this sentence. Okay, Lama, for 5-6 questions you have to write this one, then you will understand this lesson. Okay, to react with 0.3 moles of oxygen, we need okay 0.1 mole of ethanol. Okay, but we have more than that. Okay, but we have more than that. Okay, so therefore again we can say the same thing, right? But oxygen is the limiting and ethanol is the excess one. Okay, so in that way we can understand the totally added oxygen is going to react. Okay, and with that only 0.1 mole of ethanol will react. And in this side you will be seeing the reactants are formed according to their stoichiometric coefficients. Okay, so when one reacted here, 2 must be formed. When one reacted here, 3 of water must be formed, like that, working with the ratio. And then you can write the remaining row. Here 0.2 is remaining, here nothing is remaining, there is our limiting reactant. So here 0.2, 0.3 are there. Okay, and this is the remaining number of moles and this is the added number of moles. So we are sort of considering these two values when we go to the our final answer. So what's the question is asking? Now the question was taking some time. Now we might forget what they asked. No? So shall we quickly go to the question and see once again? It's asking the percentage of initial ethanol, how much percentage of initial ethanol is remaining after the reaction. Okay, so you are remaining 0.2. 0.2 is remaining. Okay, so but you added 0.3. So what you have to do? So put 0.2 as a fraction of 0.3 and then get it to the 100% because they are expecting a percentage. Okay, so that's very simple. That's how you get 66.66. Okay, because it is 2/3, no? 2 division 3, which means 66.66. Okay, right. So those who got answer as answer 3, now is it clear to you all, Laman? Now is it clear to you all? To get the answer 3, you must see that only half of ethanol is remaining. But it doesn't happen, no? Is there any more problems here? So I'm going to erase this black color 2 sentences. Okay, this is really important. You must write this one in your review. Okay, keep writing, Laman. Let's do a few more past paper questions in this week theory class also. So we have to discuss what shall we do when there are more than one reactant, more than 2 reactants. So here you have only 2, no? But there are past paper questions have given like you have 3 reactants. So we need to see how to write this sentence for 3 reactants like that. I'm going to teach you that part also this week. Okay, so we are doing 2 lessons. That's true. We are doing a huge workload. That's also true. But we are doing it properly. Okay, you are not going to miss anything. Right? I'm not going to leave anything out also. Right? So we'll be completely doing this and we are doing it faster also. Right? So that's what we need now. We need to. So I promised you at the beginning, I'm going to finish your syllabus at the January 2027. Okay, so that will happen. You can understand that will happen when we are learning and doing questions papers like that. We can achieve that goal. So let's see how to get the final answer. Okay, so remaining number of moles is 0.2 and this is the number of moles you added. Then when you want the final answer, as a percentage, you must multiply by 100%. Okay, so then you are going to get 66.67 is the actual number, because you are going to kind of rounding off now, otherwise it is not fair no. Okay, so this is the remaining amount and this is the initial amount or added amount. Okay, right. So that's a good question, study. So the most important part, as I see, because we have done this one in early also, what is more important is how did I find the moles of ethanol? You have to think in that way, okay? Don't get confused if it the molar volume formula. That's what I request. Okay. Now shall we go to the next question? That is not limiting reactant. That's not a limiting reactant question. That's a simple stoichiometry question. But again the question how they ask it is really interesting. Okay, so they are sort of focusing you to find the number of moles of a given magnesium nitrate sample. Okay, telling that it is X gram, and then you are using the same sample to dissolve in water. Right? Then they're asking the concentration of that magnesium nitrate aqueous solution. That's really interesting, right? So let's see how many of you got the answer. According to my calculations, answer is answer 3. Let's see the fourth question. Okay, see, majority of you have taken that answer, and 8 of you, that's a considerable number, 8 of you have taken answer as answer 5. Okay, let's see how it happens. Okay, let's see. Again, my advice is, Lama, if you are having any doubt further after I'm explaining, please ask. Okay, please ask. So now let's go to the discussion. So again, here it's very good. Majority of you have taken the correct answer. X grams of magnesium nitrate is there. And you are thermally decomposing that until a constant mass is given. So they have given that they are telling you what it will be forming. Okay, it's not balanced, however, right? Magnesium nitrate is thermally decomposing to give you magnesium oxide, NO2 and O2. Okay, later you will learn these reactions in unit 6 in organic chemistry, but until that I'm going to give you all the reactions necessary. Okay, right. So how do we balance this one? There are like 2 nitrogen, here only 1 nitrogen. So if I put number 2 here, then oxygen will not get balanced. So when you focus on oxygen, you will see these are the numbers we have to put. Then it get balanced. So that means 2:4:1 ratio. That is the molar ratio. Here these are reacting. And interestingly, you can see NO2 is a gas and oxygen is also a gas. Okay, so don't forget about NO2. Both are gases. Okay, and this is a solid. These two are solids. Right. So, however, the total number of moles of gases are collected in a certain vessel, and they have given data regarding that vessel too. Okay, in that vessel, the volume is 24.942 decimeter cube, and it is 27 Celsius temperature. Okay, and the pressure is 1.5 into 10 to the power 5 Pascal. Okay, so we know the volume, we know the temperature, we know the pressure. The only thing we don't know is number of moles. So how do we find this number of moles? We are going to apply another number of mole finding formula which is unique for gases. PV equal nRT. Okay, so there are two formulas for formulate to find number of moles of gases. One is PV equal nRT and the other one is molar volume equation. Remember, V division Vm. Okay, V division Vm. So this one here I'm going to apply PV equal nRT. So let's apply PV equal nRT for final gas mixture and see. So N total is equal PV over RT. So here the pressure is 1.5 into 10 to the power 5 Pascal. Or you can write it in Newton per square meter if you want. Then volume 24.942 into 10 to the power minus 3 meter cube. You must convert that one into meter cube. That is very important. And then divide universal gas constant 8.314 joules per mole per Kelvin. And then multiply that one with the temperature, which is 300 Kelvin. Okay, you have to convert that into Kelvin by adding 273. So here you will see, I can cut it with the pencil. Don't cut it with the same pen. Here it is like 3 times, and you can cancel this 3 also. So it's finally going to give you 1.5 moles. That's the total number of moles. So which means number of moles of nitrogen and oxygen. Okay, so now we need to find how many moles of each oxygen and nitrogen was there, and this is the best part of this question. Okay, so you all have to focus now. Yeah? So what I'm going to do now, you all have to focus and see, right? So let's see. You are having n number of moles of this magnesium nitrate, right? So you will be getting n moles of magnesium oxide because the ratio is 2:2. If you have n, you should get n. Understood like that? So then how many moles of NO2 will be there? Should be 2 times. It will be 2n. Okay. And how many moles of oxygen? It is 1 here. Ratio 2:1. So that means n division 2, or you can say 0.5n. 0.5n. So this total number of moles, total gas number of moles is equal to what? 2.5n. Okay. So if you just simplify this one, you will get the number of moles of magnesium nitrate. So it is equal to 1.5 division 2.5. To further go and divide, so it is 3 division 5. 0.6 total moles are there. So 0.6 are not total moles, 0.6 magnesium nitrate are there. So this is the number of moles of MgNO3 twice. So this is really important. So does anyone has any problem regarding the way I calculated? Anything to ask? Okay, just focus, huh? So if I am having 2 here, I should get 2, 4, 1. So if I am having n here, then I should get n, 2n and 0.5n. Okay, so first of all, write the balanced chemical equation and then get the stoichiometry ratios. See, and then if I'm having 2 here, that means I should get 2, 4, 1. So then you can go through the same ratio. So if I am having n here, I should get n here from this magnesium oxide. Since it is 4, I should get 2n here. And since it is 1, I should get the half of earlier, which is 0.5n. Okay, so I'm using the stoichiometry ratios now. Then that total number of moles I got in terms of n, which is equal to the total gas number of moles I found using PV equal NR. Okay, so then I can simplify and I can get n, value of n, which is the moles of magnesium nitrate. Okay, so Nisra, is that clear to you now? So it's a good concept, huh? Good concept. So now we are sort of touching the extremes of chemical calculation, ළමයි. හරි දැන් මේවා තමයි එන්න පුළුවන් හොඳම අමාරුම questions කියලා අපිට ගන්න පුළුවන් MCQs වල, right? So we are kind of touching the extreme. So now we have a clear idea what can be given as the, the best questions in the paper, right? So those are becoming ළමයි kind of difficult because of these small things. Now see here, I have to take n here to do the simplification, to show the ratio properly. Right, and so it's not the final answer, no? It is asking, you are going to dissolve the same magnesium nitrate moles Okay, so which is basically x grams now. So we are going to dissolve that one in 250 cubic centimeter water. Okay, so then it's asking what is the concentration of magnesium nitrate. So what we are going to do, we're going to divide moles by the volume. Very simple. So we have 0.6 moles. I can understand now. Why did you got 0.6? No, but it is 6, no? Yeah, some of you got the answer as answer 5 or something, no? As I remember. So anyway, we are going to divide it by the volume, which is 0.25 decimeter cube. Okay. So in this way, again, don't start dividing by 25. So, you know, we usually have small math tricks now. So you can multiply this both sides by 4. Then it becomes 1. Here it will become 2.4. So then your answer is going to be 2.4. So 2.4 moles per decimeter cube. Understood that, Ramay? Is there any question? Anything to ask? Yeah. So it is not the only way that we can do this question. Huh? So there are other methods your friends are suggesting. So those are really good. Okay, so they are formed in 4:1 ratio, right? 4:1 ratio. So you can use that ratio and find the number of moles of oxygen and nitrogen dioxide. That also works. So I'm going to write it here. Because of using this ratio, you can tell, okay, so 1.5 multiplied by 5/4, that is the moles of NO. And if you multiply that one with 1/5, then you are getting moles of oxygen. So then you are having 2 times the moles of oxygen from your compound. Okay, here you are getting 0.3 now. So then you have to multiply that one by 2 to get the number of moles of magnesium nitrate. Okay, so that also fine. Now we have set of statement questions from unit 1. It's not that difficult. We will see those questions as well. Right. Question number 5. It is asking for the incorrect statement. Let's see how many of you got the correct answer. Yeah, 15 of you got the correct answer, but 10 of you have missed the answer. So some of you have selected the answer 3 also. We'll see why it is. So look at the questions, Lama. I'm going to tell you a brief review so we can write it at the same time. So why did you take 3? Let's see first of all the first one. Alpha radiation emitted from radioactive material deflects perpendicular to the magnetic field. So what should be the explanation here? Alpha rays are, you know, charged particles. It is having a positive charge. So any charged particle is deflecting in magnetic field. And when they deflect perpendicular to the magnetic field. That is our explanation. Understood? So always, right, charged particles are deflecting perpendicular to the magnetic field. Okay, you don't need to say any direction. You have to say just it is deflecting perpendicular. So you have to establish why it is correct. So let's say first one is true because alpha particles are charged. No need to say positively charged, right? But any charged particle, so therefore deflects perpendicular. So if you want more explanation, you can write what? Fleming's left hand rule. Okay, Fleming's left hand rule. Right, so then the first one is true. Then if you go to the second one, right? Second one, what is the mistake here? Why second one is wrong? Can anyone put that one to our chat? Why second one is wrong? What is the reason? See, giving a clear sharp shadow behind the anode when a metal cross is placed. That means in cathode ray experiments, Puta, when you place the metal cross, you are seeing a sharp shadow. No? So that confirms something. It is not the wave nature. It is what? It is yeah, it's the wave character is wrong. It is explaining the very good. See, Ashima, you are telling an answer. I'm going to read your answer. The metal cross experiment proves that cathode rays travel in straight lines. See, that's a nice explanation. It's not telling you about anything regarding wave character. You haven't learned about wave character yet. So you are going to learn wave character in your next unit. Okay. Right. Very good. So I'm getting several answers. Ayuri, Ilma. Right. Yeah. Very good. Namasta. Right. Good. 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 Yeah. Yeah. Article also telling. Yeah. Very good. So they are telling you about the straight line movement of cathode rays, not the wave character. Okay, so that's why our second answer is wrong. Okay, so you have to say metal cross experiment. Metal cross experiment is telling you straight line cathode rays move in straight lines. Cathode rays move in straight lines. Right. Now let's see about the third one. Third one, some of you got it as wrong. Need to see why. Let's see once again the third one. In gold foil experiment, the deflection of fewer alpha particles in small angles confirms the existence of very small positive charged particle in the nucleus. Yes. Okay. So when they deflect, only fewer number of them were deflected, no lama. That because of the positive charge particle is there and it is really small. That small thing also explained. Understood? So you might thinking it is no need to say bouncing back lam. හරි අර bouncing back එක කියන්නම ඕනේ right bouncing back එකනොත් කියන්නේ the small solid dense nucleus is there and this fewer deflection also explain the same thing the nucleus. Okay, so what we gave in the note is positive deflection, repulsion. You have to add that one there if it is not that clear. You have to add the only few particles were deflected in that way because the nucleus is small. Okay, I'm going to give you a good review for this one. Listen, and this is our atom, right? If alpha particles are going in this way, no problem. But once they move closer to the nucleus, they deflect. Okay, so then you have to say small angle deflection due to positive repulsion. Okay, positive repulsion, right? Then you have to add that one. Only few deflected that in this way because nucleus is small. Okay, just add this one to your theory note also will bring you more clarity. Okay, so only few deflected in that way also because the nucleus is very small. Understood that one? I hope it is clear to you now. Those who got answer 3, now is that clear? So when you are marking an answer, it must be the most suitable answer. Okay, Lama? Okay, just read the second one properly. You will understand it is wrong. Okay, right. So from this week onwards, I'm going to release your marks of this paper. Okay, I think it will be a kind of encouraging thing to you to do to take participate in the paper. We will see. Okay, and fourth one, although the canal rays are not exactly formed at positive electrode. Okay, so it's explaining the same thing. We call them as anode rays because they're coming from the direction of the anode. Okay, so it's nicely explained. The fourth statement, you can highlight the whole statement. It is the reason why we call them as anode rays, because they start from the direction of anode, not from the anode. Okay, so I last week also explained we call them as anode rays because uh, not because they start from anode only, they are starting from the direction, from the side of the anode, but not from the anode. But cathode rays the opposite. Cathode rays are actually starting from the cathode. Okay, right. And if you can further explain anode, how the mechanism of anode ray formation, then you can explain it more. Okay, Laman. So please add in for the fourth answer, you have to explain the mechanism of cathode ray formation. Okay, write the mechanism of not cathode ray, anode ray formation. Anode ray formation. You can write it there. I'm going to put a question mark, so you have to write that method to your review. And then fifth one, it's from successive ionization energies we learned in this week. So it is given some values. It is given some values. 178, 178, 312. So gradually increasing. 1749 is kind of a large value, right? And 2455. So you have this sharp increment right here. So there are 2 electrons in outer shell. 2e in outer shell. It's very easy, right? 2 electrons in outer shell. So therefore, it should be belonging to the second group of the periodic table. So we'll be discussing the periodic table properly at the end of this lesson. So I mean the atomic structure. So no need to be confused about the groups and everything. Just leave it there. Anyway, the number of electrons in the outer shell is represented by the ionization energy. Okay, all right. So let's go to the next page. Sixth question. So these are kind of now some easy set of questions are there. So we'll quickly go to the discussion. It is asking, select the correct statement regarding the particles associated with anode rays. Okay. So anode rays are, they are telling anode rays are uncharged. So that is wrong. Anode rays are actually what? Positively charged. You can write in front of that. One is wrong. Why? Because it is positively charged. Okay, positively charged. And the next one, it is originating from anode, and that is also wrong. Okay, they are not originating from anode. They originate from the direction of anode, not from the anode. Okay? From the direction of the anode. That was explained in the earlier MCQ. So then second one is also wrong. You go to the third one, it is telling their charge to mass ratio, E over M ratio, depends on the nature of the gas. That one is true. Okay, E over M ratio, we discussed it in several papers, right? E over M ratio depends on the gas we take. So can anyone tell me for which gas we are getting the highest E over M ratio? For which gas we are getting the highest E over M ratio for anode rays? Okay, once the E over M means lamai, charge over mass. So if some particle or some gas, positive ion or anode ray is having a lesser mass, then it must be having a greater E over M ratio. Okay, very good. Hydrogen. So many of you have given the answer. Really good. Good. Yeah, that's correct. So that is our answer. Okay. Third one, you can add some supportive statement. Okay. This is what we call as E over M ratio. You can tell like that. Then you can explain who's having the highest E over M ratio, and you can tell even for hydrogen, its E over M ratio is lesser than the cathode rays E over M ratio. You can continue like that. Okay. Right. Then we can go to the fourth one. Their direction of travel is not towards the north pole. It's very wrong. So they don't deflect towards any pole. They deflect perpendicular to the pole. Okay. So fourth one is wrong. And fifth one, what is the mistake in the fifth one? Yeah, they deflect towards the positive electrode. No, they are positively charged. No, so they don't deflect towards the same charge pole. They deflect towards the negatively charged pole. So then fifth one is also wrong. Okay, so like that you can tell why the third one is correct, why others are wrong. Okay, very good, very good. Right, so for the online students who are participating with us via Sateha College, I think you received the practice papers, earlier paper collection also. So now you have to complete the paper discussions. Okay, once you completed the paper discussions, you have to send the PDFs. So we are checking that one. And the physical class students, anyway, in any institute, I am checking their books and also I can presently see how they are working and what they are doing, right? But online students, they have to send the discussion. Okay, right. So now we are going to focus. Okay, I forgot to see how many of you got the correct answer for the sixth one. Yeah, 23 of you got the correct answer. That's very good. Oh, good. Yeah, see the seventh one. Seventh one, you got 10, see, kind of divided. That's why I like these questions, Lama. I mean, I don't like whether you are getting wrong. හොඳේ මම ඔයාලා වර්ධිනවට කැමති එක නෙමෙයි එහෙම එකක් නෑ. Because අර මේ questions වලින් අපිට study කරන්න දෙයක් තියෙනවානේ. There are something to learn here. See, the true false MCQs are the frequently the students are getting them wrong frequently. Okay, not because they are difficult, they are easy, right? But the way they understand the question, the way should they think, they are kind of mixing. That's why. Okay, so I'm going to show you and tell you how to think in this question. Okay, so I'm sort of starting this from day one, so there'll be no issue, right? It's okay to be wrong here, so I'm telling you always. Okay, in future, once you are doing more questions, you can get improved. So seventh one, especially, I can see 10 of you got the answer 3, 10 of you got the answer 5. And 8 also the same result. Some of you got answer 4. And 9, majority of you did well. And the last one, again, answers are divided. So that means seventh one and last one, we have to give more priority for the discussion. Okay, so let's first of all see what is this fourth one, seventh one, sorry. Rutherford's gold foil experiment revealed that there are protons and neutrons in the nucleus. That is wrong. Rutherford revealed that only protons are there. Okay, he didn't reveal that. Revealing means, Lama, that you have to understand that English term. Revealing means sort of like discovering, right? Sort of like giving evidence, proving something like that. Okay, so that's that. Revealing word has some heavy meaning. Huh? It's showing, it's telling that revealing means like they are kind of proving, no? Isn't it? So therefore, Rutherford couldn't prove that there are neutrons. He only said, okay, there must be a nucleus. That's all gold foil experiment said. The proton was discovered years later. Okay, you have to write down that properly. Gold foil experiment. Okay, gold foil experiment was gold foil experiments are telling. Gold foil experiment is telling you, Lamai, only the nucleus, positive nucleus was discovered. Okay. And then our proton was discovered later. Later discovered. Later discovered by Rutherford. Okay, same person. But neutron, it was again discovered. Neutron, the idea was suggested by Rutherford, as I was explaining in the theory class. Rutherford said something neutral must be there in the nucleus to minimize the repulsion of protons, but he couldn't discover that one. Okay, discovered by Chadwick. Discovered by Chadwick. Here Chadwick, here Rutherford, here Rutherford, Geiger, and Marsden. There are 3 scientists involved. Okay, so therefore first statement is wrong. And look at the second statement. Neutron is not a type of nucleon. Very wrong, right? Neutron is a type of nucleon. So answer is going to be answer 5. So nucleons means lamai particles exist in nucleus. Write the definition, which are protons and neutrons. Those are the particles exist in nucleus. So telling that nucleon number, neutron is not a nucleus is wrong. Protons and neutrons are the actual nucleons. Okay. So therefore, both the statements are wrong. You can see that again. So some of you selected the answer 3 also. Answer 3 also. Why? That means first one is true, second one is false. So all of you have figured out the second one is anyway wrong. But those who got answer 3 have taken the first one as true. So now those students should understand why the first statement is wrong. Okay, properly understand it today. Okay, so Rutherford Guilfoyle experiment didn't reveal anything regarding proton or neutron. Okay, so it only said regarding the nucleus. So you can definitely say that is wrong because of the neutron. Can be sure about that, no? Otherwise, Rutherford is involved with the proton and nucleus both, no? But he never involved with the neutron. He didn't discover neutron. He just put the idea. That's it. And that also done years later. Right? Okay. And number 8 is again a good question. I expected that to be wrong, but anyway, most of you have figured out the correct answer. Good. And some of you got the fourth answer. The fourth answer means, yeah, we'll see. So the melting point of argon 40 and potassium 40 are not the same. Yeah, that's true. You can say Lamai, argon is a gas while potassium is a metal. Question number 8. First one is false. Why? Argon is a gas, potassium is a metal. So metal, on except for one metal, all other metals are solids at room temperature. And argon is a gas, right? So the gases are having low melting points, okay, very low, and metals are having relatively higher melting points, relatively high melting points than gases. Okay, you can understand that really well. And see, now the thing is, the both atoms are having the same mass. Can you see that? Argon 40 and potassium 40. So their nucleon numbers are same. Nucleon numbers, or you can say mass numbers, they are same. That's it. That's it. But for that, we can't expect them to be having same physical properties. Okay. Can't say because one is a metal, other one is a gas. Arrangement structure is totally different. Isotopes are having different physical properties. That one is true. Okay. So yeah, anyway, sorry, my mistake. Melting points of argon and potassium are, they are telling not the same. So they are not the same is true. Huh? Not the same is true. But Second one, again, true. They are having different physical properties, but they are not explaining each other. Okay. Why these two things are having different melting points? Because of this thing. One is a gas, other one is a solid. Okay, that's the explanation, right? Not the isotope thing. And they are not even isotopes, isn't it? They have a different name for this one. I'm not going to tell those things, but it is not necessary. Uh, yeah, when you are learning nuclear physics or something, someday you will learn. Okay? Just ignore here. So anyway, these are not isotopes that you can understand. They are not isotopes. To become isotope, they should be the same element atoms. Okay, right. So both statements are correct, but the second one can't explain the first one. See, you are choosing answer two when both the statements are true, but the second one can't explain the first, right? And look at the ninth one. The relative masses of proton and neutron are equal. It's true. We say it is 1 equal to 1, right? And it is also given in the question. But when you go to the actual masses, the actual masses are not that equal. Okay. So who's heavier? Tell me, Lama. Which one is heavier? Is it proton or neutron? Yeah, very good. Neutron is heavier. Good, good. You remember the theories, no? Okay. Yeah, you can go to your theory book. In your tut 1 for atomic structure, you have that theory point. Okay. Neutron is heavier. Neutron is heavier. Okay, good. Yeah. And therefore, you can say the first one is correct, second one is wrong. Answer 3. Answer 3. So question number 9, majority of you have selected the answer 3. And 4 of you have selected answer 5, which means both are incorrect. And that can't be, no, Lamai? Yeah, no. The relative masses are equal. Okay, we go with 1. No? It's relatively 1. Relative and actual and relative and true are two meanings. Okay. Just write a good review. That will be enough. On the review එකක් yeah, let's see. Last question. Last question. Atom is not the smallest particle of matter. That's very true. Atom is not the smallest particle of matter. Everybody can understand, right? There are further smaller particles. So what's the reason why the first one is true? Why the first one is true? This is a good question, Lamai. So we'll finish with a good question. Okay, listen. Give me a few minutes. So why the first one is true? So in the 10th one, first one is true. Why? Because there are electrons, protons, neutrons, which are smaller than atom. In other words, there are more particles, but these are the things we discuss for A levels. No? These are called as subatomic particles. So subatomic particles are smaller. That's why first one is wrong. This must be the reason. So in your second one, this if the second one is there, this should be the reason. But in second one, look at what they have given. Atom is the smallest particle of matter that can keep the properties of the element. That is also true, but it is not the reason for the first one. So don't select answer 1. Okay, answer should be answer 2. So I hope now you can see here. Can you see, Lamai? Most of you are confusing with answer 1 and 2. That's what I'm showing here. Okay, let me classes වල සෑහෙන ලොකු effect එකක් ඕගලන්ට හොඳ දෙයක් ගන්න තියෙනවා. ඒක හරියට කරගන්න. Okay, there is a huge thing you can gain from the class. Okay, see those who got answer 1, right? I know I saw few kids are having 4, no, the total mark of the paper is 50 now. So 45, 45, 45. I saw several 45s. I think some of them got this one wrong. Okay, not because they don't know, they got the statements properly, but once they are relating the second one to the first one, they got confused. That's why they got the answer one. Not the answer is not the answer one long. Okay, so the both statements are true, but second one can't explain the first one. Focus on that. Some of you got the answer properly. I'm happy. That's good. Okay, but still, see, okay, the other 10 students have to focus more. And 6 of you got the first one is wrong. Yeah, that means Lama atom is not the smallest. That is true, right? First statement is true. Those who got answer 4 tells first one false, second one true, no? Isn't it? But it can't be, no? First one is also true because there are subatomic particles. I hope that doubt was cleared by the statement I gave in the board. But for the people who took answer 1, has to think more, okay? Understood that. Are there any more questions? Yeah, so Namaste is telling because atom has subatomic particles within itself, making it not the smallest particle of matter. Yes, that's on the statement, right? Yeah. So I wrote in a different way, but it is telling like this, and I'll read it again. Because atom has subatomic particles within itself, making it not the most small, not the smallest particle of matter. So atom is having further smaller particles inside. Okay, Lama. So I hope you understood the question. 10th one is really important. Are there any more doubts? Anything to clarify? Both statements are true, but second one can't explain the first one. That's the logic. Huh? That's the logic. Okay, so that's it for today, Lama. I hope you understood something, gained something. So write a nice review and finish your reviews and show it to me. I'm going to check them in the class. So I'm doing this one just to make sure you do the work. Okay, right? So this for your own benefit. හරි වැඩ කරන්න ඕනේ ළමයි රිසල්ට්ස් දාන්න බෑ වැඩ නොකර right ඉඳා මේ හොඳට ගේම ගහමු right so the work you are doing you have to do it properly right so yeah if there is any more doubts you can always ask right so I'm going to finish today's class now okay good night study well and see you all in the next class